Okay, just
Hello,
speak
sir.
up again. Tatu.
Hello, sir.
Hi,
Yes,
I
sir.
can hear you now. Right.
How are
One.
you?
I'm very well, thank you. And yourself?
Yes, sir.
What are we busy with?
During the week, I was busy doing acids and bases.
Okay. Right.
Yes, sir.
Do you have any questions?
Not necessarily. It seemed like straightforward thing,
Okay. Have you done
a
anything?
straightforward topic.
Sorry, I didn't get that.
Titration. I've also been doing titrations,
Okay.
and I think can I please open my study
Yeah.
book, because I think that's the way it is.
Okay, so there is some titration.
Okay.
Look, you've got two sections in acids and bases. Theory with Arrhenius models and Lowry Bronsted models, or your textbook might use the term Bronsted Lowry. So that you must learn. Is that correct? Have you done that?
Yes, sir.
Do you know what a conjugate
Yes,
base
I
and
have.
acid is? Do you know what a conjugate base and acid is?
A conjugate base and acid.
That's theory.
Yeah, it's in the theory.
Yeah, it's theory.
I think so. Isn't like a please repeat the term, sir.
Conjugate.
I think isn't it like a strong acid like that ionizes completely and forms a high concentration of like
No, that's a strong acid. What you need to know is how to determine conjugate base and acid pairs. Okay. Let's
yes, sir.
quickly look at that. Just quickly look at that. Let's look at your Bronsted Lowry. Your Bronsted Lowry theory or model.
Yes, sir.
You know what that is? What is a acid according to a Bronsted Lowry model? An acid is a proton donor. Is that correct?
Yes, sir. And
So
a base is a
gives
receiver.
away a proton. And a base?
Yes, it's a proton receiver.
Okay, proton receiver. So it means it actually receives a proton.
Yes, sir.
Okay. Right. So for instance, I do a basic one. We take hydrochloric acid and we ionize that by adding water to it. You'll get hydronium ions and chlorine ions. Is that
Sir,
correct?
can I be asked?
Yes.
Sir, it is correct. Can you write it the other way around? Can you write chlorine ions plus H3O proton?
Yeah. Okay.
Oh, okay.
You can write it. Okay.
Oh, okay. Yes, that's what I wanted to ask, because I thought you're only supposed to write them like a certain type of way.
No, but the top reaction is the ionization of hydrochloric acid. But you're right, the reaction is reversible. This reaction is not really reversible because hydrochloric acid is a strong acid.
Yes, sir.
So it will ionize fully. It won't go back. This reaction won't take place. The bottom one won't actually take place. Okay. Anyway, but yeah.
So what I was asking, you see the one at the bottom,
Yeah.
chlorine and H3O. Can you write it like that on the top, on the product side?
But it is on the product side, on the top.
Yes. Can you write it like the other way around, like Cl negative plus?
It doesn't matter. Eh?
Oh, it doesn't matter.
No, it doesn't matter.
Okay, that's what I wanted to know.
It doesn't actually matter at all which one's first and which one's second.
Oh, okay.
Okay, anyway, so how do I know that hydrochloric is an acid? Or why is it an acid according to Lowry Bronsted? Because it donated a proton to water. That's correct. Sir. So this is an acid. And the one that received the proton is a base. Now, hydrochloric acid becomes chlorine ions when it loses its proton.
Yes. Yes.
This is called a conjugate base. Conjugate base. While the water becomes hydronium ions, which is a conjugate acid.
Yes, sir.
Did you do any of this work?
I wrote some note, but I haven't. I was busy doing titration for the past week, so.
Okay. We can do titrations if you want to, but this is a part of the theory that's quite important that you'll
Can I
have to
write
go
this down,
through.
sir?
Pardon?
Can I write this down?
Yeah, but there's a section in your textbook that you will have to do actually.
Yes, sir.
Let's spend a couple of minutes just on this,
Okay, sir.
just so we can
So,
make sure
okay.
this is not difficult. This is easy work.
So, okay, so can I be asked? A conjugate base is basically a product formed after the reactant acid has donated a proton.
Yeah, the conjugate base is the product that forms when the acid loses its proton. And a conjugate acid forms when the base accepts a proton.
Yes. Okay, so.
You just need to be able to identify conjugate base and acids.
Yes, sir.
I'm
Sir, can I please ask?
Yeah.
In the exam, are they gonna give me like a sum where they don't give me like the chemical formula of the sum? They just give me the words, then I have to write it myself.
Not necessarily. I'll tell you, we'll do a couple and then I'll show you how they ask it in exam.
Yes, sir.
Okay, and then we'll go over to titrations. So let me just look at a couple of examples. I'm gonna copy and paste a couple of examples here. Let's just do this one first. I don't remember if we've done this. I'm not sure. Okay, then I've got water added to acetate ions, and that gives me acetic acid, which that plus is wrong there. It shouldn't be there. I don't know what it's doing there. And I have to fix that. And OH ions, hydronium, hydroxide ions.
Yes,
I'm
sir.
gonna fix that one. Control F4. There we go. Okay, so identify the acid and the base on the left-hand side of the equation or at the reacted side. Which one is the acid and which one's the base? Which one is donating protons or hydrogen ions?
So
Identify the acid between
sir.
these two red ones. Which one is the acid and which one's the base?
the H3COO negative, that's one acid.
Nope.
And
Nope. Not at all.
that's a base.
The water is donating a proton to the CH3COO minus. Look.
But sir,
Yeah.
I thought you said acids.
Which one is the acid?
So sir, is water like the acid?
Yes. Look. There we have water there, and water becomes OH minus. Here we have acetate ions and becomes acetic acid. So what happened to this acetate ions? What happened to this one here? Well, it became that one on the right-hand side. It was given another hydrogen ion. You see that? So it received a proton, which makes this thing base. It becomes an acid or a conjugate acid. Conjugate acid. Can you see that? It received. Yes, so the water, it's called an ampholyte. Ampholyte means it can be either a base or an acid. This is the acid. And this becomes a conjugate base. Very important. It's extremely important. So an acid loses a proton, it gives it away, and the one that receives the proton is a base. Let's do another one. This is very important theory. It's supposed to be 3 marks because it's not difficult. I'll show you how I do it. It's very easy actually if you do it this way. I'm just going to look at NH4. This is another example. Just going to look at NH4 and I'm going to make a dot on the right hand side of the equation to match up its partner. It's obviously NH3. Can you see that?
Yes, sir.
Those two are
Yes, sir.
partners. So how did NH4 become NH3?
By donating
By
one
donating a proton.
hydrogen.
Yeah.
Yes, sir.
So it donated, making it the
An
acid.
acid.
And this one becomes the conjugate
A
base.
conjoint. Yes, sir.
Very good. There's my one pair. And the fluorine ion received one. So that's a base. And it becomes a conjugate acid. Conjugate acid. Okay. Now in the exam, they might ask you to write down the acid and conjugate acid base pairs. So you might be able to write them down. In other words, they can ask you, write down the conjugate acid and base pairs. Then you can write NH4 plus is an acid. And NH3 is the conjugate base. And then I write fluorine ions is a base. And hydrogen fluoride is the conjugate acid. That's one way of asking it. Or they can just ask you the following. They give you HCO3 minus, and then they ask you, what is the conjugate acid? What would the conjugate acid be of HCO3 minus? Then I say, okay, fine. If I have to find a conjugate acid, it means HCO3 minus must be a base because a base becomes a conjugate acid. How would that, if that is a base, if this one is a base, in other words, what would make it a base? It would receive a proton.
An H, yes, sir.
So the conjugate
Hydrogen.
acid will be the base after it's received another hydrogen. So it becomes H2CO3. And then I don't have a minus anymore because I've added a plus. Because you added a proton, the two charges will cancel one another.
Yeah, oh, yes, sir.
If they ask the following, HPO3 2 minus, and they ask, what is the conjugate base?
Then we just take out the H, then it'll be HPO3 in negative. I think.
Think again. You take out the base, you take out the hydrogen, so it becomes PO3 2 minus and another minus, which is 3 minus.
Another minus.
Yeah. If this is an acid, if we want to know what the conjugate base is, it means this one is an acid. So it actually donates that proton. So we lose a proton. And then I lose another positive charge, which makes the overall charge 3 minus. This is quite important. You need to write this down or screenshot it or whatever.
Okay, so can I write?
Yeah, write it down. This is theory, a part of your theory that they expect you to get full marks for.
Okay, so
not that difficult.
This is so confusing.
Is it confusing?
To a certain extent, so it is. Maybe I haven't gotten used to it yet.
You haven't studied it, that's why.
Yes, sir.
Now, what you need to do is take these notes and then you go through that section. You know, it will become much clearer after you do a couple of examples.
Because I also tried to look at my textbook, but in my textbook, there's so much It's so much theory. Yo,
Oh. But you must just remember not to try and study it. Just
yes, sir.
read through it quickly. Just read through it. So you get a whole picture of what you should be able to do. So you've got Arrhenius model. You have a Bronsted-Lowry model. Then you have strong bases, weak bases, strong acids, weak acids, and definitions for that. And you have to learn a couple of strong acids off by heart. Then you have conjugate acid and base pairs, which I'm showing you now. And then the final part of it is titrations, part of the chapter. So there's a bit of theory that you'll have to actually go through and get the hang of. And there's also ionization and dissociation of acids and bases.
Yes, sir.
Good.
Base HA.
And there's amphylite.
Yes, sir, which is like a substance that can either be a base or an
like
acid.
water.
Yes, sir.
Well, this
Also,
hydrogen,
water.
water is an amphylite. This is an amphylite. This one is an amphylite. They can either be acids or bases. Yeah.
Okay.
Tell me when you finish. I'll show you.
Okay, sir. HCO3 negative receives an H atom.
Yeah. What is the conjugate acid? If you want to find the conjugate acid, it means that one must be a base.
Yes, sir.
So I treat it as a base. Give it a proton.
Yes, I'm done.
So look at this. If I gave you exactly the same example, HCO3 minus, and I ask you what is the conjugate base, then this means this one is an acid.
That acid, yes, sir.
It will donate a proton, and it will become CO3 2 minus.
Too
That
much.
is the conjugate base.
Oh, because we are removing like we
Hydrogen.
are removing a hydrogen.
Yeah.
So therefore,
Yeah.
we also minus by the minus also. We add
Yes.
another.
Yes.
Okay.
The overall
Okay,
charge you will lose one positive charge. So the overall charge will be one negative one.
Oh, so every positive charge you lose, there will be one more
extra electron
negative
available.
one.
Yeah, extra electron.
Okay, okay. Now I get
And
it.
let's
Okay,
book
sir.
titrations. Right. What is a titration?
Titration is basically a base or an acid neutralizing each other. Yeah.
Yes. Okay, that's a very dumb picture. It's not a good quality picture. I'll just try and do another one. Just try and get this picture better. Just going to copy and just show you what you basically physically going to do, what a titration is physically. You're right. It's a neutralization reaction between an acid and a base. So you can either make up an acid or make up a base or titrate a base on an acid or an acid on a base. So in other words, you take like an Alumire flask or a conical flask. There we've got it. And then you can put, let's say you put a base in there. Right, don't worry about the flea that's in there. A flea is just a, don't worry, it's not a real flea. It's a little magnet that spins. So it stirs the container automatically. So there's a container. And let's say we've put a base in there,
Yes, sir.
like sodium hydroxide.
Also, can I ask you a question before we
Yes.
proceed, right? So that means in every balanced equation, it's an acid and a base.
It doesn't have to be an acid and a base. Every acid and base reaction is an acid and base. You can also get other type of reactions like combustion reactions or ion transfer reactions and stuff like that. All reactions doesn't have to be acids and bases.
So
Wherever there's
when-
wherever there's proton transfer, then it's acids and base.
okay, so can I ask, so if I'm give like a balanced equation between an acid and a base, and they say I must balance the equation, I can use the thing of transferring one proton, right?
Yeah, but you can balance the equation without transferring. You've learned how to balance equations last year already.
Yes, sir.
But if it's I know what you're asking. If they just give you the two reactants,
Yes, sir.
and you have to write the equation, then you can do proton transfer, yeah. But it's not that easy. You have carbonates as well. I'll show you just now. It's not that easy. Remember, there's something you have to learn. An acid plus a base gives you a salt and water.
Yes, sir.
Acid and a carbonate base gives you a salt, water, and carbon dioxide.
Mhm.
An acid plus a metal gives you a salt and hydrogen gas.
Yeah, yes, sir.
Okay, now we have a base there, sodium hydroxide. Then you put in a indicator. Do you know what an indicator is?
It's a thing that changes color and determines
Yeah.
whether it's an acid or a
There's three
base.
indicators
Yes,
that
sir.
you have to learn. Phenolphthalein, methyl orange, and also what's bromotamyl blue or something like that.
Oh, yes, sir.
Okay, you must learn which one you're going to use when. So for a strong acid and a strong base, you use the blue one. For a strong acid and a weak base, you use methyl orange. And for a strong base and a weak acid, you'll use phenolphthalein. Okay, anyway,
Yes,
bottom
sir.
line, I'm going to add or titrate acid onto that base, like hydrogen chloride. The minute all the sodium hydroxide is neutralized, then the color of the indicator will change. It will change from blue to like green. And then your reaction is finished. Have you seen this?
Yes, sir.
Okay, now let's do an example. I'll show you two ways how to do this. They're going to tell you, okay, we're taking the sodium hydroxide. It's a solution. And we're taking
Yes, sir.
25 cubic centimeters of that solution.
Okay.
What unit is that?
What unit is that?
What is
Oh,
it saying?
okay. If we're converting it, it's volume, sir. Just liter.
Yes. And a cubic
Milliliters, yes, sir.
centimeter is the same as a milliliter.
So you divide by 1,000 in order to find.
Very good. So to convert to cubic centimeters to decimeter cubed, you divide by 1,000. It's
Yes,
the
sir.
same as converting milliliters to liter. You divide by 1,000.
Yes,
Okay,
sir.
anyway, we're adding that. We're adding hydrogen chloride to that. And that will give me a salt, which is sodium chloride plus water.
Whoa, whoa, whoa.
Hmm?
So I'm trying to see something.
Okay, look at this.
Okay.
There's my one metal, sodium,
Yes, sir.
and that's going to react with that chlorine ion.
Okay,
Give
sir.
me a salt.
Oh, then the remaining H goes to
Remaining
the...
is water, yeah. So what you can do if you struggle, just take the water away, and then what remains will react with one another.
Yes, sir.
So acid and a base gives me salt and water. Sodium chloride is just table salt.
Yes, sir.
Okay, but we are adding the acid, and we're adding 0.015 cubic decimeters. Now, very important, we're using two different type of units, and the concentration of that acid is 0.2 moles per cubic decimeter. Square brackets is shorthand for concentration. So I want to know, what is the concentration of the sodium hydroxide?
of the sodium hydroxide.
Yeah, what's the concentration? There's two ways to do titration examples. The one is just through a titration. One method is just titration formula. The titration formula looks like this. Na
Na divided by NP
is CV.
equals CV. Yes.
I don't really like that. But
I've seen,
it's very
I
good
see it
for,
as
yeah,
the easy one. Yes, sir.
that is the easy one. But you know what? It works really well for easy examples, but it's
Yes, sir.
really lousy when the examples becomes really difficult. Just remember
Okay.
that.
Yes,
So
sir.
in a straightforward titration, this is the best way to do it. Okay, so now I see that the mole ratio is 1 to 1.
Yes,
1
sir.
mole of acid reacts with 1 mole of base. Then I just fill in the equation. What is the concentration of the acid? 0,2. What's the volume of the acid? Oh, well, I can use 15 milliliters or 0,015 cubic decimeters. Now, with this titration formula, you don't have to worry about the units, the volume units,
Yes.
as long as you use
Because
the
they
same units on top and bottom. Okay.
Yes, sir.
So at the bottom, I want to know what's the concentration of the base. I don't have that. And the volume of the base is 25.
0,0,25.
Yeah,
0,025. Yes, sir.
So now I'll just multiply across. 1 times CB times 25. Okay, you said 0,025. 0,025. And that equals 1 times 0,2 times 0,015. And then I just solve this equation. Let's get a calculator. Just solve this. 0.2 times 0.015. And I divide that
Equals
with
0,12.
yeah, well, the concentration of the base is 0,12, and you have to write mole per cubic decimeters. Bang.
Oh yeah, mole per cubic.
Otherwise, you don't get any marks. Zilch.
Yo.
Yes.
Okay,
Okay,
that's not fair,
method
sir.
method 2 is normal stoichiometry. So I'm going to go to the HCl and work out its mole. The mole is the concentration times the volume. The concentration is 0,2 and the volume is 0,015. So I just type that into my calculator.
Which is 3 times 10 to the power of -3.
Mole. Bang.
Yeah.
Right, then I look at my mole ratio and I realize that the sodium hydroxide will have the same amount of mole because it's a 1-to-1 ratio.
Yes, sir.
And then I work out the concentration by taking the mole and dividing it by the volume. 3 times 10 to the power of -3. And the volume of the sodium hydroxide, I think it's like 25 divided by 1,000 or 0,025. So I divide that with 25 divided 1,000 on a fraction. And then I get obviously the same answer, 0,12 mole per decimeter cubed. So there's a straightforward titration. You can use any method to solve it.
Yes, sir. 25 divided by 1,000, which equal to 0,212 mole per decimeter.
Good.
Yes, sir.
Another example. Right. The next example, I'm going to take 4,9 grams of sulfuric acid.
Okay, sir.
And we're going to dilute that. No, we can't dilute the solid. We're going to add 220 milliliters of water. First step. Then, in a titration, we find that 20 cubic centimeters of the solution is enough to neutralize. Neutralize is an important word. Neutralize, let's say, 28 cubic centimeters of sodium hydroxide. Right, so what we've done basically, drawing little pictures is nice because there's our container, our conical flask. And in that flask, we have 220 milliliters of water. 220 milliliters of water. And I'm going to add 4.9 grams of sulfuric acid. Bang. Good. That's the first step. So they might ask you in 1.1, what is the concentration of the sulfuric acid solution? What would the concentration of that solution be? So that's just the first question. And we're going to do the titration just now. But they want to know, what is the concentration of that sulfuric acid? Right.
Okay.
You can do that.
Okay, let me try. Okay, so can I be the 4.9?
Yes.
Is that like
Sorry, it's gram, it's gram.
it's grams?
Yeah,
Okay.
sorry.
We're trying to find the concentration.
Yeah.
Okay, what you're gonna do is we're gonna try and find the mole, which is N equals to mass divided by the molar mass.
Okay.
Which is
Mole.
4,
Molar mass.
it's 2 plus 30.
4.9 divided by
2 plus 32 plus what's 16 times 64 plus 64, which should give you about 98.
no. I don't care about that. I'm just going to type it straight into my calculator, all of that. That gives me 0.05 mole of acid.
0.05 more, yes, of then from there, yes, C equals to N divided by the volume.
Yes. Okay. Now it doesn't matter. The mole is 0.05 and the volume is, now I have to use 220 divided by 1,000, eh? I have to use,
Yes, sir.
can't use grams. I don't know. Do you get 0.227?
0.220, which gives you 0.23. Okay.
I get 0.2272.
I just did the thing. What do you call this again?
Rounding off.
Yes, I rounded off.
Okay, we must just make 100% sure there's a difference between 2 decimals, which is 0.23, and 3 counting numbers. No?
Yes, sir.
3 counting numbers would have been 0.227.
Yes, sir.
Which one do you need to do? 2 decimals.
Yeah. We need to do the. Is it 3, sir? Isn't it right to the nearest?
Yeah. Look,
two decimal places?
CAP syllabus requires 2 decimals, while your IEB syllabus requires 3 counting numbers.
Okay, sir.
So you're gonna, well, whatever.
Yes, sir.
I've luckily got that value still there,
Yes, sir.
which I can use if I doubt. Right, let's go. The second question. I want to know, what is the concentration of the sodium hydroxide? Okay, now I must read, and I must continue drawing a picture. Because out of this, we didn't use all of that acid. We only used how much?
A
small amount.
20 centimeters.
Yeah, 20 milliliters now.
Yes, sir.
So 20 milliliters we used in our experiment. We also need an equation. Otherwise, we can't do it. Okay, this they'll give. No, I'm not going to expect you to write out the equation. So there's the reaction between the sulfuric acid and the sodium hydroxide. It gives me sodium sulfate and water.
Yes, sir.
And if I balance it, I get this. That's the balanced equation. But I only use 20 milliliters of the, so,
Yes, sir.
and the concentration, so the volume is that, and the concentration was 0.23.
Yes.
And I've got the volume of sodium hydroxide, it's 28 milliliters.
Also, do we also have the moles of the sulfur?
Yeah,
Sulfuric,
yeah, okay, you can use any method. I'm going to show you two ways you can think of doing this. The first one was to use the concentration, because remember, the concentration in the big flask and the concentration in the small flask is the same. The mole differ. There's a difference between the mole of the small one and the big one.
yes, sir.
So if you take like any alcohol or something, this is an easy way to explain it. If you take a bottle of brandy, for instance,
Yes, sir.
the percentage alcohol is about 43%. If you
Yes, sir.
pour out a little bit in another glass, you also have 43% alcohol in the small glass.
Yes, sir.
But the mole, the molecules of alcohol in the big bottle is more than in the small glass. But the concentration is the same. So one way we can reason is by using concentration. So I can say, look, I've got the concentration of the sulfuric acid in the small jar. It's the same as in the big one. And then I can say,
Yes,
okay,
sir.
fine. I can use this formula. Na over Nb equals Cv over Cv. Now, so
Yes,
the
sir.
ratio of acid to base is 1 to 2. You see that?
Yes, sir.
The concentration of the acid is 0.23, or yeah, we are allowed to use 0.23 because that was an answer. Or you could have used 0.2272 if you wanted.
Yes, sir.
And then I times the volume, which is 20 milliliters. I don't have to convert to liter now.
Oh, yeah, yeah, yeah.
Milliliter on top and bottom. Then the concentration of a base, I don't know, and the volume is 28. So I'm basically going to multiply 1 with C and with 28. So I get 28C. And that is 2 times 0.23 times 20. And then I'm just going to solve this equation. You know what I'm doing now. You understand?
Yes, sir. But this one of like saying we find out that only 20 milligrams of the substance was used, it kind of confuses me, I won't lie.
Okay. No, fair enough. But it doesn't matter how much we used because the concentration stays the same.
Yes, sir.
And in my titration example, I used the 20 mol. So this is assuming, this way we assume that the concentration equals the concentration in the beginning and the final concentration is the same. There was another way of doing it. I'm just going to do it here somewhere. Come. There's another method. And you can say, look, we can use the mole. That is using mole. So you can say, look, the H2SO4, I can work out the mole in the small jug, in the 20 milliliter jug.
Yes,
Why?
sir.
I have the mole in the big jug. The mole in the big flask is 0.05 mole. We worked that out. Remember?
Yes, sir.
Where is that? There. And I'm only using 20 milliliters out of the total 220 milliliters. You see that?
Yes, sir.
So if I do that, 0.05 times only 20 out of the 220, I get 4,45454 mole. This is the amount of mole in the small jug. So this is the mole in the 20 milliliter flask.
Yes, sir.
Then I can go to my sodium hydroxide and say, look, the mole is in a 1 to 2 ratio. Sorry, I've got a mistake here. I made a mistake. I didn't write times 10 to the power of minus 3 with the mole. Okay, to just move that. So that is times 10 to the power of minus 3 mole.
Yes, sir.
So the mole sodium hydroxide is 1 to 2, so twice of that. 4,5454 times 10 to the power of minus 3 times 2. So I'm just multiplying with 2. Then I get the amount of mole is 9,0909 times 10 to the power of minus 3.
Yes, sir.
So now I have the mole of sodium hydroxide. Now I can work at the concentration. The concentration is the mole divided by the volume. So that is my answer, 9,0909 times 10 to the power of minus 3 to divide with the volume, which is 28 mole. Now I have to convert to cubic decimeters because I'm using normal stoichiometry to do it. So I'm just going to do answer on top of 28 divided by 1,000. And my answer is going to be slightly different. Why? Look at the difference between the answers, and I'll explain to you why. This one is 0,33, and this one is 0,32.
32, yes, sir.
Because we use this rounded off 0,23 value instead of the 0,2272. So this mole one is slightly more accurate, actually, because we didn't need to round off right till the end.
Yes, sir.
So I'm going to test you on this one quickly.
On this type of problem.
Pardon? I'm going to test.
On this type of problem.
Yeah, what's the problem?
Okay. I'm ready.
Okay. Right, let's go. I'm going to give you a balanced equation.
Yes, sir.
But
You're going to give a
CH
balanced equation.
Yeah, this is a balanced equation for that. That's called acetic acid.
Yes, sir.
It's an acid.
Oh.
And I'm going to add calcium hydroxide to that. And that will give me CH3COO 2 calcium plus water. Liquid. I'm not going to worry about the subscripts now. So I'm going to have 2 there and 2 waters there. Right. So I have acetic acid plus calcium hydroxide will give me calcium acetate and water.
Yes, sir.
Okay, so let's start the sum. I'm taking 7 grams of acetic acid. And I'm adding it to, let's say, 250 milliliters of water. 250 milliliters of water. That's the first thing I'm doing. Then 100 milliliters of this solution is used to neutralize, let's say, what? 85 milliliters of calcium hydroxide. Right. First thing, 1. What is the concentration of the acetic acid? Do that first. What would the concentration? Yeah, a little. Yeah, you can write it down. You have lots of time. I'm just going to make a drawing of that. That is like 250 milliliters of water.
Okay.
And I'm adding that acid, 7 grams of acid. So I want to know, what is the concentration there?
COOH. Okay, can I please just throw my flask? Yes, sir. Then I add 7 grams. Hey, what the hell? 7 G's, and 215 milliliters of water. Okay, let me just solve this for you faster. Equals 7. Okay, this thing is 12 plus 4 plus 12 plus 32 equals okay. We say we're finding the concentration, right?
Yes. Okay, let's do. Tell me when you're ready.
Okay, so let me just finish this thing on 165 250 divided yo oh 0 4 6 0,467. Yes, so we can start.
That's correct. So the mole is the mass over the molar mass.
Yes,
7
sir.
grams over, there's 2 carbons, so that's already 24.
4
Plus
32
plus 2 times, yeah, oh, you're right, 32 plus
plus 4.
4. Okay. That gave me what?
That gave you 0,116 or 0,117. I wrote 0,1166. I just made it 4. Yes, sir.
Okay. Well, it's very important that we don't round off there, really,
Yes, sir.
because we might want to use that other method in which we use the mole ratio. So that's like 1 and then a couple of 6s. I'm just gonna make sure I'm using like a couple of 6s. Well, that would be enough. Okay.
Yes,
I'm
sir.
going to use answer anyway. So the concentration is the mole divided by the volume. And that is 0,116666, whatever, or answer, divided by
250 divided by 1,000.
very good. So that divide by 0.25. And then I get that the concentration is 0,46666. So the concentration is 0,47 mole per cubic days.
Yes, sir.
Good. Now the next question would be, I want to know what's the concentration of the sodium hydroxide. What is the, not sodium, calcium hydroxide. What is the calcium hydroxide's concentrate?
It's
Okay, well, how are we going to do that? You can choose any one of those 2 methods.
okay. CaOH. Okay, we're trying to find the concentration of calcium. Yeah, is this calcium?
Calcium
Calcium
hydroxide.
hydroxide. Okay. So, are we trying to find the concentration, right?
Yeah.
Okay. I'm looking at the mole ratio, which is 1:1. Therefore, the moles
Which
of
method
the
are you going to
subs.
use? Which method are you going to use?
Sir?
Which method are you
I'm
going to
gonna
use?
use the mole method.
Okay, the mole method. So you're going to start off
Yes,
with
sir.
the CH3COOH, eh?
Yes, sir.
How many moles are we adding to the smaller basket, to the smaller bottle?
Is 0,11666. What?
Mm,
Oh, sir. Oh, whoa. Okay, let me throw another flask.
how many moles are we adding to that 100 ml flask?
How many moles are we adding?
Yeah, look, we started off with 250 ml flasks. Now we're only
Yes, sir.
using 100 ml of that solution. How many
Yes.
moles is that?
Can I just calculate quickly?
Yeah.
It's 100 over 250, sir. Multiplied by 100 over 2.
250. This is an accurate method. Okay, so it's
Which-
0.11 and a lot of sixes times
Yes, sir.
100 over 250.
Yes, sir. Which is equal to 0.046664.
That's how many mole I'm adding. Now look at the what? The ratio of mole ratio of calcium hydroxide and acid.
Yes, sir.
So what's the ratio? So 2 to 1. So the mole is half of that
Yes, sir.
because there's a 2 to 1 ratio. So I'm just dividing that with 2. So the amount of mole is 0.02233 mole. Good. Then I can work out the
Yes.
concentration. Concentration is mole divided by volume.
0.04666 divided by 2. So, n is equal to 0.2333.
Good.
Like, therefore, C is equal to N V, which equal to 0.0233 divided by 0.085.
Yes. But I would always recommend doing this in the test. It's just,
Yes, sir.
you can just pop it in a calculator.
Which is 0.27
Mole per cubic
445.
meter. Very good.
Yes, sir.
Awesome.
Mole.
Okay, make sure you've got those notes.
Yes, sir, I do. So not actually that hard if you practice it.
Yeah,
Now
if
that I
you
see it.
practice this, it's not that difficult. It's
Yes,
not that
sir.
difficult.
The thing,
Okay. I just want to
yes, sir.
just do one more concept quickly. It will take 5
Yes.
minutes.
Okay.
Okay. HCl, there's a couple of strong acids that you have to learn. This is an example of a strong acid. And a strong acid will ionize fully. You'll have to learn that. But you must be able to understand the following. If I take a big jug and there's like, there's 20 liters of water in that jug.
Yes, sir.
And I just put in 15 milliliters of that acid. Then it's going to be what? It's still going to be a strong acid. Remember, it's still a strong acid, but it's only very what? Diluted.
Yes, sir.
So you can have a strong acid that's diluted. So it's the very low concentration. So you have a low concentration, but it's still a
Yes, sir.
strong acid. On the other hand, you can have an acid like, say for instance, acetic acid we've just used. That is a weak acid.
Yes, sir.
And you can take a weak acid and let's say you take 20 milliliters of water. It's not a lot of water. And
Yes, sir.
we add 50 milliliters of the acid. So there's more acid than water.
Yes, sir.
Then we still have a weak acid. But it's concentrated. So you can have a weak acid that's concentrated, a weak acid that's diluted or low concentrate. You can have a strong acid that's also concentrated, or a strong acid that has a low concentration or diluted. Do you understand this?
Oh, okay. Can I write it down? So
Yeah.
yes.
It's very important. So in other words, you're using the right terms for the right thing. You're not using wrong terms. If you take an acid and you put a lot of water in it, it remains a strong acid or a weak acid. It doesn't change from strong to weak or from weak to strong.
Too strong. Yes,
Yeah,
sir.
it just as the concentration values differ.
20 liters of H2O. It's still strong acid. Okay. Diluted, which is low concentration. Okay.
But you can't understand that. Okay?
Yes, sir. Well,
Okay, that's it. You'll have to go and do the theory, study the theory in this chapter. There's quite
yes,
a
sir.
bit. And then I'll see you next. I just want to make sure. No, there's something I want to ask you. I have a problem on Thursday, I think. Just want to check. I was wondering if tomorrow's lesson, is that tomorrow?
Yes, sir.
Thursday? Wanna have
Yes,
a
sir.
look at
It's
that?
tomorrow.
Yeah, I was wondering if we can't have that on Friday. Just want to check if that's the problem. Yeah.
Yes. Yes,
Tomorrow,
sir, we can.
can we just have Friday 10 o'clock?
Yes, because tomorrow I'm not even coming to school, sir.
Okay, so it will suit you as well.
Yes, sir.
Okay, I'll see you Friday at 10 o'clock.
Yes, I'll see you then.
Okay, excellent.
Bye.
Bye.